Hi everyone. I think we're going to start now. I'm sure there'll be people coming in later, so just bear that in mind. First of all, thanks for coming, and I hope you had a good summer break. So you've not had a talk since July, so thanks again for coming. Before I introduce Stephen Pulman, I'm sure you can introduce yourself in a better way than I can. And also the talk. I just wanted to say that we've got some future talks as well. So on 21st of October, we've got Rob Carver, who's just written a book called Systematic Trading. Apparently there have been no books before which have been called Systematic Trading, which I thought was quite interesting. But he was the head of fixed income at AHL, so he's a very knowledgeable guy. And I've met him, and he's definitely well worth coming to see to speak. And he'll have some of his books as well. So if you want to buy a book and have a signed copy, please do come along. And if anybody knows anyone in New York, I'm speaking next week at Thalesians on Thursday on trend following strategy. So please pass on the word. But without further ado, I'd just like to introduce Stephen.
Well, as I'm a computer scientist, so I don't know anything much about trading other than you're supposed to kind of buy low and sell high. That's about it. So I'm not going to try and make any sort of obvious connections. I'll make some connections to this stuff and what you folks do, but I'd be very happy for you to make other suggestions. Okay, so what I'm going to do now in a sort of pretty informal way is to give an overview of different types of what's broadly called sentiment analysis. There's sentiment analysis proper, which is the business of classifying text into positive, negative or neutral attitudes towards the things mentioned in the text, probably along a scale or with some associated probabilities. But there are a number of other signals that we can get out of text. Not perfectly, we can't do sentiment analysis perfectly either, but we're getting to the point where we can do it accurately enough that I think it's useful. So I'll talk a little bit about signals of future intent and risk. We also are beginning to pick out what you might call demographic properties of the authors of text. I'm not going to talk about that today because I just haven't got time. But I will talk about deception, which is an interesting sort of angle that we've started to work on over the last year or so, and also say something about detection of emotion in text. I'll say a bit first about the kind of tools that we use. I'm not going to give lots of technical stuff because this isn't the place for it, but there are several different approaches that any kind of computational linguistics group will have in its repertoire. The kind of oldest, I suppose, dates from what you might call symbolic AI days, which is you can think of as a kind of pattern matching, but a pattern matching that's linguistically informed, in that rather than looking for particular keywords and combinations of them, you can look for rather richer patterns, and you can build in variants in such a way that variation in the way something is expressed that isn't important can be abstracted away, allowing you to capture the things that are of interest. And in fact, that linguistically based pattern matching is just in itself is a really useful technology. You can build what's called an information extraction system just using that. An information extraction system is one of the success stories of computational linguistics. There are a number of successful companies using that technology to do things like mine the biomedical literature for evidence of protein interactions or protein folding, that sort of thing. And the kind of patterns that I mean are things like this, where you have when you write the pattern, you write person behind the scenes. That's compiled out into all the different things that your system thinks is the name of a person, and then some simple regular expression, some verb that expresses somebody's been chucked out of position or moved on from it or something, and then a company role. And we can, as I say, build quite successful systems just using that technology. So it's going from unstructured text to structured data. You're asking, you're like an analyst, you're asking the same 3 or 4 questions of every text you read. Machine learning methods, obviously over the last 10 or 15 years, have become, in academic circles, the dominant paradigm for doing almost any kind of computational linguistic processing. And these vary in how complicated they are to understand and to implement, how long it takes them to train, what kind of data they need to train. But at a higher level, what you're doing is casting your problem as a classification problem. You're saying, here are some example texts that have been labelled with one, typically a small number of labels. Learn some features of those texts that predict the label, and then use that to classify new texts. And you can use your favourite machine learning algorithm to do that. The very simplest one is the so-called naive Bayes, which is just a simple conditional probability model, astonishingly effective a lot of the time, actually quite difficult to beat. You can have more complicated things like support vector machines, and these days you all have heard about sort of the fashionable deep learning methods, which the kind of dominant deep learning method changes month by month. So this month it's long short-term memory models, last month it was convolutional neural networks, and next month who knows. They all work. These, if you can get the right data and you've got lots of kit to train them on, the deep learning methods do typically give you a couple of percentage points more accuracy over the more traditional machine learning methods. But that's in academic life. Out in the real world, you often don't have the kind of data that you need to train these models. Sometimes you don't have any data at all. In that case, you've got to build a system just based on the kind of experience of the computational linguist. Getting high quality annotated data is typically very expensive. It takes a lot of time. If you can get it, then machine learning methods are often the methods of choice. Okay, so let's talk then briefly about what I call sentiment analysis proper. So people have been doing sentiment analysis in this sense for about 15 years now. And in the simplest case, it's the classification, as I said, of text as expressing a positive, negative, or a neutral attitude. So this stuff in green, traditionally we have green for positive, red for negative. The stuff in green, I think everybody would agree, is an unambiguously positive review of the Bond movie. The red is an unambiguously negative review of the Bond movie. The one in black is actually, or should be, neutral. So it's not actually expressing an opinion at all. It's just describing some aspects of the plot of the movie. But you'll notice that it has a couple of words in it which in isolation have a kind of negative connotation, so breach and rogue, and my guess is that many systems would wrongly classify that as negative. So that shows you that even a simple three-way classification is not trivial. Actually, even detecting that something expresses an opinion is quite tricky. You can build a sentiment analysis system in an afternoon, actually, not a very good one, but one that has been good enough to get many a start-up on the road. And what you do is just collect, these are the so-called lexicon-based approaches. You collect lists of positive and negative words. There are a number of these out there on the web that you can get. You can harvest them actually by doing some simple corpus processing tricks. So if you start out with, say, 10 unambiguously positive words like great and excellent and some unambiguously positive words, build a model of the linguistic context in which they occur, just in a window of 3 or 4 words on either side, and then look for other words that occur in that same window, and they will likely have the same sentiment value. So you can very quickly kind of bootstrap yourself up to several thousand of these that way. So having got that, you classify a new text just by counting. So if it's got more positive than negative, it's positive, or negative positive, more negative when it's negative. As we'll see, that's not ideal, so it'll miss a lot of stuff. The better thing is to do what most commercial systems do. You get a training corpus, which has been annotated for sentiment, and you can either get people to do it, or one trick that people often use is to harvest reviews from review sites, especially those with a star system, and you assume that the 5-star reviews are positive and the 1-star reviews are negative, so that gives you a kind of automatic labelling of the data. It's not foolproof, but it's a good one to get started with. Any machine learning system can't deal with words, it has to deal with numbers, so you transform the text by just counting the number of occurrences of words and represent that as a vector. And you can either have real counts or just binary vectors, and then train your favourite classifier. Okay, these all work reasonably well. As I said, there are still lots of problems. Both of these systems will be a bit baffled if the text is equally balanced between negative and positive, won't really know what to do. And in some sense, the idea of classifying a whole text as negative or positive is a bit odd, because most real texts are going to be a mixture of sentiment. And so you really want to capture that, and these things don't. The fact that you're just doing word counts, or maybe a bit more sophisticated model counts of successive pairs of words, what we call bigrams in our trade. But for the most part, you're throwing away any grammatical structure. So and producing a so-called bag of words model where you've lost all the grammatical information. And that means that a sentence like Airbus orders slump but profits rise is going to be regarded as exactly the same vector, or give rise to exactly the same vector as Airbus orders rise but profits slump, whereas the sentiment is probably quite different. And also there are some really tricky effects when you combine words, and this is actually what got us interested in sentiment analysis as an intellectual problem about 10 years or so ago now. And it's this. Typically a negative word will reverse the polarity of what it combines with. So if you say this is great, it's good, not great is the opposite. But in some circumstances it doesn't. In particular here, so if we take clever on its own positive, the word too somehow has the property of making almost everything negative. So too clever. But funnily enough, if you now negate that, then not too clever is still negative. Okay, so that's not what you predict at all. And the more you look, the more of these kind of phenomena you find. This is a sort of made-up example, but it demonstrates it. So bacteria on its own, you'd say negative. Kill on its own, you'd probably say negative. Kill bacteria, that's usually positive. Fail to kill bacteria, that gets negative again. Never fail to kill bacteria, positive. So that's now what you've got is essentially 4 negative words, but combined in such a way that the overall thing is positive. So we sort of looked at this and decided that the right way to treat these kind of things was to regard it as an aspect of what linguists call compositionality. Compositionality is the idea that the meaning of a sentence must be some function of the words in it and the way that they're put together. The meaning of a sentence must be predictable from its components and the way they're put together. And similarly, the sentiment value of a sentence is predictable. So what we try to do is to use the grammatical structure of the sentence, which in this case we represent as this kind of hierarchical structure, and we can, these days, automatically parse sentences, at least well-behaved text, reasonably accurately. We can get it right about 70 or 80% of the time. If it's well-behaved, if it's Twitter or something, all bets are off. And essentially what you do is you use this hierarchical structure to work out the sentiment values at successively higher levels of the... So we'll say that killing bacteria, although killing bacteria are negative, killing bacteria is positive, fails is negative again, never fails is positive again, so the whole sentence is positive. And the way that we do that is to have, in the system that we built at TheySay, it's built on based on some work done by one of my DPhil students, Lawrence, who's the co-founder of the company, was to write a whole lot of, well, partly write and partly harvest, a whole lot of rules triggered by the presence of particular words and particular grammatical constructs. And the rules say things like this: if you kill something negative, the result's positive. If you kill something positive, the result's negative. Killing kittens will get bad press. If you combine 2 with almost anything, it'll make it negative, and so on and so forth. And we've got a very large number of those rules that try to cover as many of the phenomena of kind of general English as we can. Now, general English, of course, will not get everything right, because when you move to a particular domain, like finance or medicine, then particular words will take on a sentiment polarity that it wouldn't have in the general language, and you need to tweak things to get that right. So that works pretty well, and most current systems that achieve good accuracy on the kind of benchmarks that we use something like that principle. They may not implement it in the same way, and people spend a lot of time trying to get machine learning methods to behave compositionality, including some of my students in Oxford. We've still not solved all those problems. There's a big problem about context dependence of words. So a word like cold beer is generally good, but cold coffee generally isn't. And so that's something that you need to try to get right. And then things that depend on who's producing the language. So for me, I never use wicked in anything other than a negative sense, but of course most people under the age of 30 do. And teenagers, so for me, sick is unambiguously negative, whereas my son, talks about a sick night out as a great night out. So you need to know who's, what's the demographic profile of the person producing these sentences in order to know what the product sentiment is. We've also only got the text. We don't know anything about the person reading it, and depending on their interests, something might be perceived as positive or negative, as in this example. So I've got a horribly inefficient oil-fired Arga, so oil prices are down, good. But it costs a bomb to fill the thing up. But if you're an investor or a government trying to reap in taxes, then oil prices are down, is not so good. And of course, sarcasm and irony is just unbelievably difficult because, again, we've just got the text, and most of the time, detecting sarcasm and irony is detecting a mismatch between what somebody's saying and what you know they believe, and we don't have that thing. Excuse me. So, sentiment analysis, then, straightforward. We can do it. We can do it reasonably well. Certainly well enough to be useful. There are a number of other signals that we've begun to extract because some of our customers have been interested in them. In particular, expressions of intent and expressions of risk. We started out trying to treat this as a kind of classification problem, but it's really difficult to get a corpus, because if you take an average text, the number of expressions of intent and risk in it are going to be quite small. So actually, it turns out to be much better to treat this as a linguistic pattern matching problem and just write a bunch of patterns, because the number of ways in which people express an intention to do something or express that something is at risk, it's not small, but it's not huge either. I mean, there's a few hundred patterns will capture almost all of the things correctly. And you need to tweak them a little bit, trial and error. But why would you want to do this anyway? There are really just 2 kinds of areas that we've found where people have been interested in doing this. One is in your area. So in the US, there's this legal definition of forward-looking language, which is anything that's basically not about the present. And one of the interesting things that we've found working with people, people have often tried to, analysts in particular, have tried to use sentiment on things like company reports and earnings reports. And they're surprised to find that company reports are very... Do you want to move position? Or can you... I see you breaking your neck to try to... Not better? Okay, thanks. And company reports, unsurprisingly, are often, nearly always positive, because a company's writing about itself for its shareholders, for the press. They're not going to shoot themselves in the foot. So you might think, on the basis of sentiment, companies doing really well. But if it turns out that the percentage of forward-looking language is relatively high, then that positivity should probably be tempered. If it's low, then they probably are doing well, because they're talking about what's actually happened. But the most obvious application of this is in so-called intent to churn messages. A lot of companies spend a lot of time trawling social media and other channels, looking to pick up customers who are about to jump ship because they're dissatisfied with the offerings. And the fastest way of getting your broadband problem sorted out is to tweet something about O2 or BT or something, so this is rubbish, and you'll get an answer very quickly. Especially if you say, I'm going to move to Virgin. Okay, so here's some typical examples of that application. Okay, let's then talk a little bit about deception. Deception's a kind of interesting thing, often quite difficult to define. Here's one definition. You've got A and B, and some proposition X. A believes X to be false. A causes B to believe X or to continue to believe X via some piece of evidence, typically a statement, where B takes that as evidence for the proposition in question. Notice that I haven't distinguished between intentional and sort of accidental deception, and really should do. In face-to-face interactions, I think we're probably reasonably good at detecting deception, but at least within people in your own culture. I think cross-culturally it's more difficult, because you've got all sorts of signals, people's eye movements, their vocal quality, the way they hold themselves, and those kind of non-linguistic cues have proved to be quite effective at training a classifier to detect. There was a famous example where people rigged up, sent a bunch of people with false passports through a border security thing, and a bunch of people with true passports, and trained video cameras and stuff on them, and were able to, on the basis of those kind of cues, detect to about 70% accuracy which people were trying to get through on a false passport. This must have been an experimental situation, of course, because you wouldn't want to mess about trying to do that for real. But it shows that those kind of non-linguistic cues can be quite powerful. And of course, in text, we haven't got that. We haven't even got spoken, in speech, we're missing all the visual cues. Nevertheless, a lot of people have thought it's worth trying to see whether you could build some kind of system to detect deceptive language on the assumption that there may be some linguistic cues that are characteristic of deceptive language, and that you may be able to pick up on well enough to distinguish the two. Again, in the general case, you're never going to be able to do it, because what's deception is going to count on facts about the world, which are not necessarily going to be represented in the text. So what are the linguistic characteristics? Well, there's been a whole sequence of studies over the last 20 years or so, really. Some of them collecting corpora to examine by setting things up. So you get a bunch of students, you tell one of them to convince their classmates of something that they don't actually believe in, typically via email or something, so they can collect the transcripts, and another bunch to try and convince their classmates about something they do believe in, and then compare the linguistic properties of the two collections of texts. And there have been quite a number of studies like this. Another way of trying to do it is to get transcripts of court proceedings, and then for the person who's been found guilty, you assume that they were telling a lie in their evidence, and retrospectively kind of classify the transcripts, or chunks of transcripts in that way. That's been done by some of my colleagues at Essex University in quite a large scale for Italian court cases, which I was really surprised at. So I thought, the bureaucracy involved in trying to do something like that in the UK would be incredible. I assume that in Italy, you'd need an act of parliament or something to get that kind of data. Anyway, they got it. They probably bribed somebody to. Anyway, all of these studies have converged on a number of characteristics. So, liars tend to use more words expressive of strong emotions. They tend to use more negations, and curiously more motion verbs. Why that should be, I just don't know. People telling the truth use more first-person references compared to liars. They use a lot more words that are indicative of caution in some way. Sort of, I think that, I believe that, maybe, such and such, except. And what seems to be the case is that liars are kind of exaggerating things, and certainty. We think she does protest too much and stuff. And don't associate themselves very closely with the content because they know it's not true. So they don't say I and me and we, whereas truth tellers do. And truth tellers are also kind of more willing to accept alternatives. They're not as straight on as liars. There's a splendid study which some of you may be familiar with, which took these cues and looked at transcripts of post-earnings announcement conversations between CFOs, CEOs and analysts. You probably read lots of these, I haven't. And the assumption was that in some of these cases people are not telling the truth. How do you tell that? Well, you look at what happened in the 6 months following. And after the earnings release, if the CFO mysteriously moves on, or the CEO resigns, or they change their accountants, or the earnings are restated, or something like what happened to Tesco last year, then somebody was not telling the truth. So these two guys looked at a large number of these transcripts, and on the basis of these subsequent events, distinguished a truth-telling from a deceptive class, and trained a classifier using most of the features that I've been talking about to try to learn to distinguish the two things automatically. And they got it nowhere near 100% accuracy, about 68% accuracy, but better than a baseline. And what they found was that they could as I say, they could distinguish the two accurately enough to not necessarily make money, but avoid losing money. It works out that if you were invested in the portfolio of deceptive companies, you could lose quite a bit. So we've been trying to replicate some of that work and build on it in Oxford. We've been building what we call a verisimilitude classifier, which looks out for these linguistic indicators, also looks out for other things as well. We try to think of it as a kind of general measure of information quality, so we have various measures of kind of readability, how straightforward is the language, are people trying to obfuscate things and disguise things, is there a lot of kind of so-called hedging, where you're kind of saying, well, it may be such that, as opposed to being certain. And we got that to work reasonably well on some of the baseline texts, and we've had a huge amount of fun applying it to political text. So we did a PR stunt by monitoring social media coverage of 4 party leaders in the last election. Actually, we did the Scottish referendum as well, and we'll do the US election when that eventually happens. And it's actually very interesting to do this, certainly in terms of sentiment profiles, and we're always very clear we're not trying to predict the outcome, because you can't do that on the basis of social media, because the people who use social media are representative proportion of the voting public. So we looked at the 4 party leaders, and what do you think? Surprisingly, who do you think of the 4 were it seems a long time ago already, isn't it? Clegg, Cameron, Miliband and Farage. Who do you think came out as displaying the least amount of deception? So no political affiliation will be deduced from this answer. It was Farage. And I think when you look at his written transcripts, you can see why, because he uses very simple, very straightforward sentences, man of the people, no nonsense kind of stuff, whereas all the others are kind of hedging things about and being very difficult to pin down. So I hesitate to say that they're all liars, but what you can say is that there's a very high incidence of the cues associated with deception in all of their speeches. Okay, let's move on to emotion now. We've worked on this for a couple of years. Other people have worked on it for far longer. When we start building a system to detect some new signal, we obviously just go off and read the academic literature to begin with. And it's very confusing. So I've worked in psycholinguistics in the past, and so I go to that literature, and a very influential paper distinguishes 5 basic emotions. All of the other emotion words, at least, are regarded as semantically complex combinations of the primitive ones, involving the relationship between the verb and an object, whether there's causation involved, and which direct way the causation goes. A different classification, also from the psychological literature, comes from a psychologist called Paul Ekman, who's written a number of books on emotion and its expression in faces. He has, well, at least in one of his books, has an extra emotion, surprise. Elsewhere he actually has 7 basic emotions, but we'll stick with the 6. And he claims that there's a close correlation, that you can recognise these by the expressions on people's faces. To some extent, and to some extent you can see that's true. Joy and sadness, yeah, I'm kind of less convinced about the others. I think they're quite difficult. For me, they're quite difficult to tell apart. If you told me that was anger, I'd agree, but if you told me it was disgust, I wouldn't think that was too implausible either. So anyway, 6 basic emotions correlated with facial expressions, and you can see how these give rise to emoticons, which sort of count as symbolic representations of this. It's an interesting thing then to discover, since we assume that facial expressions are universal, to see whether the set of emotions is also universal. And this turns out again to be not completely straightforward. To begin with, there's what I hinted at on the last slide. It turns out there are cultural differences in the interpretation of facial expressions and relating them to emotions. So Japanese and US subjects mostly agree on happiness, surprise and sadness, but much less so for anger, disgust and fear. They're much less easy to tell apart. And the other question to ask is, well, is just the basic set of emotions, are they universal in the way that the set of colour words is universal, more or less? And there's some interesting anthropological examples here. There's this community called the Ifaluk, if that's how you pronounce it, in some group of islands, that probably rapidly disappearing islands in the Pacific. And anthropologists have tried to classify their emotion vocabulary and came up with this particular word, which really just doesn't seem to fit into our classification at all. Again, I don't know how you pronounce it, let's call it Fargo. So Fargo is felt when someone dies, they're needy, is ill, or they go on a voyage. So that sounds like a fairly negative emotion, sort of sad or something. But it's also felt when in the presence of someone admirable or when given a gift, which just sounds like a completely opposite sort of emotion. So that, if that's true, then that's an emotion that really just doesn't map onto our emotional vocabulary straightforwardly at all. You have to be cautious, of course. There may have been translation difficulties. It may also have been just that these people winding up the anthropologists, because it's good fun to do that. And there have been some well-known examples of crazy anthropological findings which turned out to just be a joke by so-called primitive peoples that were looking at. Nevertheless, I think it gives us cause for thought. Okay, so how do we set about building an emotion classifier, an automatic emotion classifier based on text? The first thing you try and do when you're building something like this is see what's the upper bound on performance. How well do humans do it? So on well-behaved text, humans will agree on sentiment classification about 85–90% of the time, so pretty high. Getting them to agree on different classifications of emotion, there is statistically significant agreement, but again, wide variation between different emotions. So pretty good on surprise, on sadness, not so good on surprise. So we shouldn't expect figures up in the 80s. So the next thing you do if you're trying to train a classifier is get the data. And I've already said that getting a lot of high quality annotated data is very expensive and difficult. The group in Queen Mary here in London and other groups as well, including us, have experimented with what's called distant supervision. That's a bit like the movie review thing, trying to infer the labels that you're interested in from other labels, and in particular using Twitter and the hashtags and emoticons that people include in their messages. So hashtags are very interesting things, and they started out, I think they were intended to be a simple kind of topic classification device, but they've taken on this sort of life of their own. People use them as a kind of meta comment on their tweet, they fold it into the body of the tweet, they can be whole compressed sentences sometimes, a lot of information in hashtags. So anyway, the idea is you harvest lots of tweets. That you can do that easily because the Twitter API is free. It's very depressing to look at most of it. And you collect these and you look out for the tweets that have an unambiguous emotional hashtag, like hashtag hash happy, hash angry, and so on and so forth, and also some emoticons. When you look at these, very often, some of them, because people are talking about stuff you have no idea about, often the hashtag is the only thing you can make sense of. So this one here is, I don't know what hash blue waffle is, but I know that this is a pretty upset person. Anyway, collect lots of data like that. Again, with Twitter, the great thing about Twitter is just scale, so you can collect millions of these relatively quickly. Are hashtags and emoticons equally good as indirect labels? Well, no. Matt Purver and his colleagues did a sort of test with people and found that there's much less agreement on what emoticons mean as you go from the kind of well-known ones through to the more obscure ones. If somebody put that in a tweet to me, I think they just dropped their coffee or something. I wouldn't have a clue what it was supposed to mean. So we probably need to do some filtering on that. So they did some experiments on training a classifier using this data, and the results were not actually that good. I mean, they were okay, but not that good. What they did find, though, was that if you added a small amount of high-quality annotated data, even just 1,000 or so tweets where somebody has painstakingly gone through and annotated them with the correct emotion, the results got significantly better. So you can boost mediocre data by having a small amount of good quality data. Still not brilliant. So training on emoticons and training and testing on emoticons and hashtags here are the so still happy, sad, and angry are reasonably good, whereas fear, surprise, and disgust are just awful. Sorry, I should explain. I guess you probably precision is the things that were there to get right. How many of them did you get right? How many false positives were there? Recall is how many of the overall things that you actually spot, and F is the mean of the two. And usually in these kind of things you can tweak a dial. If you're interested in recall, if you don't want to miss anything but you don't mind getting some false positives, you can loosen things up to do that. If you're interested in high quality, you want the things to be right, but you don't mind missing a few, you can tweak the dial so that precision is improved. But this is just the mean of them. So again, these are good enough to be useful, but these aren't. These are pretty bad. So then hashtags are useful, emoticons less so. If you can add some good quality annotated text, then that will help a lot. Notice the difference. The earlier sort of face recognition stuff here was quite good, whereas here it's not. So we've again used this technique, and also one of the nice things about being in a university is that we have large numbers of impoverished students we can persuade to annotate data for not much money. So we've got quite a lot of high quality annotated emotion data and trained up a classifier. This emotional language doesn't seem to show much of the kind of compositional properties that I talked about in connection with sentiment. So straight classifiers do pretty well, as well as anything linguistically more sophisticated. So we've been using various kind of neural networking kind of things to do this, and we're getting quite good accuracy. And some apparently useful application. We've got some customers using it in finance. A big area for us is healthcare monitoring. Local authorities and regulators are just desperate to avoid another mid-staffs kind of tragedy, where all the warning signs were there about poor treatment of patients, and even newspapers in the mid-staffs case, and also in social media. So all the local authorities have these health watch things where they're processing survey reports and websites where patients are encouraged to record their experiences, and we have a lot of customers doing that. So that seems to work reasonably well. Here's the application in your area. You're probably all familiar with Richard Peterson and the market psych thing, which was recently brought up by Thomson Reuters, I think, wasn't it? So Richard has argued for a long time that even different asset classes respond to different emotions. But here's a good example. So this was the swine flu epidemic. The World Health Organization declared it an emergency. Lots of people on social media saying, "Ooh, I'm not going to go on an airplane in case I catch swine flu." So people think, well, airlines aren't going to be busy. I'll disinvest from them. And the effect of that was that the price of things like American Airlines came down, which had bought a bunch at $4.81 and sold it a week later for quite a lot more. So if you can track that kind of fine-grained emotional response, then that may well be able to earn you some money. There's a well-known paper by Johan Bollen and some colleagues who also claimed that calmness, a particular emotion, calmness, would predict the Dow Jones index. This has been almost universally panned in the literature. People have complained about the methodology and nobody was able to replicate it. So, although I think their study's not so good, I think in general it is the case that people get some kind of predictive value. We've been using it in politics again. One of the nice things you can do in natural language processing, it's quite easy to mix technologies, and as well as detecting emotions, we can do things like topic classification. What is this text about? And it turns out that these are obviously fictional candidates, but we really did this for the general election. You can discover which topics the voters are most worked up about, or most angry about, or happiest about for each candidate, which is very valuable information if you're a party manager, because you can tell your candidate to keep his mouth shut about immigration because it's attracting lots of hostile press, or play up the stuff about the economy, because people seem to really like that. So we can classify, cross-classify with these things. And again, I think we haven't tried that in the kind of finance area. I think that would be a really interesting thing to try out. Different emotions about different topics, rather than just the emotions full stop. Okay, time's moving on, so I will conclude. So I hope I've convinced you that we can detect a number of different types of signal over and above straight sentiment. There are lots that I haven't talked about. We try to detect humour reasonably well. We try to detect advertisements, because of course they're always positive, so you just want to filter those out. We do that reasonably well. And we're moving on to some of these demographic properties, which again are, they're sort of, some of them are not too bad. I mean, we're not too bad on gender in certain types of text. Again, with gender, there are subtle things. I mean, there's some obvious things, like if it's about football, it's probably men. If it's about handbags, it's probably women. But there are some subtle linguistic things as well, which we've learned how to detect. But for all of these, really, what would be great would be to have much better quality training and testing data, so that we can, firstly, we can build better systems, and secondly, we can actually put a metric on them. At the moment, different groups are not always that willing to share their data. So if somebody says I'm getting 85%, somebody else says I'm getting 86%, you have no idea whether that's a meaningful comparison, because they're not using the same data and they're not agreeing on the metrics. So we need to do that. We need to be more scientific about this kind of stuff. But because there's so much commercial interest in it, that often gets pushed to one side. I think I started out doing the emotion classification a bit unwillingly, really, because I wasn't convinced there was anything much to it. But the more I worked on it, the more I think actually it is interesting, that it somehow gives you a much more interesting causal explanation of the attitudes that people have, rather than just simple positive and negatives. Of understanding what emotions are involved gives you, I think, a lot more insight than just positive and negative. And also, we're pretty excited about the deception stuff, which is only in beta at the moment, but in all the things that we've tried it on, it seems to work really well. There's a simple web interface to our API. We have two products. We have an API and a dashboard, and I'm happy to talk to everybody afterwards about those. But you can play about with the API and try most of these things. Not all of them are in the API, but you just cut and paste a bit of text and see what the system gives you. It'll get it wrong, some of the time, because it's natural language processing, and we do get it wrong. It's a difficult task, but our stuff there, you can see when it goes wrong, why it's gone wrong, and so on. So I encourage you to play about with it, and that's the end of my talk.
Has anyone got any questions?
Sometimes in newspapers, images or pictures can be classified easily as positive or negative. For example, if there are flames, if there are, depending on the objects, if there are weapons, it's negative. Would you think it would be possible to associate the feeling, the sentiment of a picture, the text itself, in order to maybe enhance the precision?
Well, that's a very good question. I think the answer is, if you can get the training data, yes. I mean, people are beginning now to be able to automatically detect emotions in faces. There's a couple of companies, there's one called Emoticons, who have this great demo where they hold a camera to your face and it tells you what emotion is being displayed, and it's quite accurate. And there's also a lot of work on correlating images with text. So in Google, you probably saw in the press, have this sort of demo system which will generate a caption for an image. So all of those things, I think if you get high quality training data, then you can do it.
How effectively can you distinguish speculation from fact?
It depends how the speculation manifests itself. What we do is look out for words like might, suggest, appears.
Right.
So
That's what I mean, speculative language.
yeah, so and we got interested in that again, actually in combination with the information extraction work, because if you're mining scientific articles, you're picking out. So we were, in this particular case, we were picking out protein A interacts with protein B. Now, what you want to do is to distinguish the cases where it says this data suggests that protein A interacts with protein B, from the cases where it says this data demonstrates that protein A interacts with protein B, and that's what we tried to do. So we can do that reasonably well, in fact. Again, because the range of linguistic variation for expressing those kind of things is not enormous, particularly in scientific writing.
At the beginning, when you said this example of kill bacteria, never fails to kill bacteria, you say you deal with this problem by 75,000 rules and decompose these sentences. How did you get rules? I mean,
my DPhil student spent 5 years.
Okay, so manually.
Partly manually, partly processing corpora, partly going through the Cambridge grammar of the English language to get all the constructions. So a lot of hard work.
You need a lot of students.
He is slightly obsessive, I should say, which helps.
Okay. There's an interesting kind of case for looking at classifying positive and negative sentence, etc., which is in race reports, where there's a standard set of phrases and terms which are used to indicate that ran on means that the course did very well, pulled back, etc., etc. So that would be kind of an easy way of testing how your classification stuff would work, because you could, with a machine would do, because you can manually just go through these things and just pick up the words and say, yeah, this is a good report on how the horse performed in a particular race, etc. So I wondered if people have ever tried that out.
We tried that, and it's really difficult because there are two things. Firstly, is the kind of domain-specific use of language. So often, if it says the going is hard, most of the time that would be negative. But for a particular horse, that might be positive. So that's one thing. The other thing that we found really difficult was actually just picking out references to horses automatically, because they have such a range of names. And there's one horse that's just called Say. And you can't assume that things are nicely capitalised and so we did try picking out sentiment for particular horses and for particular riders, and it was not very accurate. But it's a really good thing to try. We didn't know. It was a student project, so there wasn't much effort. Somebody wants to pay us to do it, spend 6 months on it, I'm sure we could do it a lot better. But it is really interesting.
You mentioned market site. Are there any things that you think your system does better or worse than they do?
Well, we do things that they don't do. I suppose the honest answer is I don't know. You'd have to look at the output of both systems on the same text and see. In general, I'd be surprised if our system wasn't more accurate, because whenever customers in particular have tried it against the other commercial offerings, we've always come out ahead on accuracy.
What sort of things do you think you're better at?
Well, partly these kind of tricky compositional cases, partly being able to, and our sort of general purpose system straight out of the tin does reasonably well on all sorts of different texts, but if we're wanting to customise to a particular domain like horse racing or finance, then with a bit of work, it's much easier to kind of customise our system than it is to retrain a big deep neural network.
Yeah. 75,000 rules is a lot of work. In practice, especially for specific applications in narrow domains where you've got some labeled data you want to basically apply a machine learning algorithm and hope you get something useful. The question that always arises is what are some good feature types that perform well in sentiment analysis, or at the very least better than a bag of words representation, but don't require hand coding 75,000 words.
I don't know the answer to that question. The kind of lines of research that we've been pursuing is trying to learn those features automatically using in particular convolutional neural networks. Can't give all the details, but basically you learn these little feature filters, which are kind of small windows that you go over the text with, and it learns to recognise particular combinations of words wherever they are in a text. So it kind of automatically learns something like the rules that I had up. It doesn't do it as well, and it'll only work on data that's like training data, whereas those rules are pretty general purpose. They'll work reasonably well on all sorts.
So are you looking at something like this as subset of skipgrams, or?
Yes and no. That's a kind of separate dimension representing words as word embeddings, which we also are beginning to do. I should say that for us, the main incentive for working on these machine learning alternatives is not to improve the English system, because they don't usually. It's to make it easier to move to other languages, because I'm not going to get another bunch of DPhil students who are willing to spend 5 years on German and 5 years on Spanish and so on. So it's the ease of moving to other languages is the big attraction for machine learning approaches.
If there are no more questions, I'd like to extend another round of applause. It's definitely a very interesting talk.